Let me ask you something. When was the last time you died? No, don't look at me like that. I'm serious. Because if I told you that most of the atoms in your body right now were not there a year ago, you'd have to admit that the you from last year is gone, physically gone. And yet here you sit, thinking you're the same person. So which is it? Are you alive, or are you the ghost of someone who already vanished? By the end of this talk, I want you to see something that most people never think about. I want you to understand what physics actually says about dying, and I think you'll find it says something quite surprising. Not comforting in the way a preacher might comfort you, but surprising in the way that only the truth can be. Let's start with something simple. Let's start with a candle. You light a candle. The flame flickers. It burns for an hour, 2 hours, and then it goes out. Now, I ask you, where did the candle go? You might say, well, it melted. But that's not really an answer, is it? The wax is mostly gone. The wick is a little stub of char. Something happened to all that stuff. Where is it? Here's where it gets beautiful. The wax was made of long chains of carbon and hydrogen atoms. When the flame burned, those atoms didn't disappear. They couldn't. They combined with oxygen from the air and floated away as carbon dioxide and water vapor. Every single atom of that candle is still out there, right now, drifting around the room or out the window, mixing into the atmosphere. The candle is gone, yes, but not one atom of it has been destroyed. Not one. This is the first law of thermodynamics, and it is one of the most fundamental facts in all of physics. Energy cannot be created or destroyed. It can change form, it can move from one place to another, but the total amount, it stays exactly the same, always. Now, you might say, fine, Feynman, that's a nice trick with a candle. But what about me? What about a person? And this is where it gets really interesting. You are made of atoms, about 7 octillion of them, give or take. That's a 7 followed by 27 zeros. It's a number so large that if you tried to count them 1 per second, it would take you longer than the age of the universe. And those atoms, every single one of them, were here long before you were born, and every single one of them will be here long after you are gone. Let me put it another way. The carbon atoms in your muscles were once inside a star. Not poetically, not metaphorically, literally. The carbon in your body was forged in the nuclear furnace of a star that lived and died billions of years before the Earth even formed. Here's how that works. In the early universe, right after the Big Bang, there was almost nothing but hydrogen and a little helium. That's it. No carbon, no oxygen, no iron, no calcium, none of the stuff you're made of. So where did it come from? It came from stars. When a star like our sun burns, it's smashing hydrogen nuclei together to make helium. That's fusion. But in bigger stars, heavier stars, the process goes further. Helium nuclei smash together to make carbon. Carbon and helium fuse to make oxygen. And it keeps going, up through neon, silicon, all the way to iron. Layer after layer, like an onion of elements, each one cooked in a furnace hotter than the last. And then, when the star can't burn anymore, when it runs out of fuel and the core collapses, the whole thing explodes. A supernova. And in that explosion, all those elements, the carbon, the oxygen, the iron, they get flung out into space. They drift through the galaxy for millions of years. They mix with clouds of gas, and eventually they get pulled together by gravity to form new stars, new planets, and on at least one of those planets, new people. So there's a very real sense in which you are stardust. Every atom of calcium in your bones was manufactured in a dying star. The iron in your blood, same thing. The oxygen you're breathing right now was cooked up in a stellar core and scattered across the cosmos in an explosion so violent it briefly outshone an entire galaxy. Now wait, let's be careful here. Let's think about this more slowly, because there's something even stranger going on. Those atoms that make up your body right now, they're not staying put. They're passing through you. There's a beautiful experiment, and I love this one. Scientists tagged phosphorus atoms with a radioactive marker and tracked them through the bodies of rats. What they found was remarkable. The phosphorus in the brain of a rat, and also in mine and yours, is not the same phosphorus as it was 2 weeks ago. In just 14 days, half of it has been swapped out, replaced by new phosphorus atoms from the food the rat ate. And this is not just phosphorus. This is everything. The atoms in your brain, your muscles, your skin, your bones, they are constantly being removed and replaced. You eat a potato. The atoms from that potato get broken down, carried through your blood, and built into your tissues. The old atoms get carried away, exhaled as carbon dioxide, flushed out, sweated off, given back to the world. What this means is staggering if you think about it carefully. The atoms that are in your brain right now, the ones doing the thinking, the ones processing these very words, they are not the same atoms that were there a year ago. They are, quite literally, last week's potatoes. And yet you remember what happened a year ago. You remember your childhood. You remember your name. So what is this mind of ours? What are these atoms with consciousness? I'll tell you what they are. They are a pattern, a dance. The atoms come into your brain, dance, a dance, and then go out. They're always new atoms, but always doing the same dance, remembering what the dance was yesterday. This is what you are. Not a collection of stuff, a pattern, a configuration, a way that matter has organized itself temporarily, beautifully, into something that can look up at the